Hello everyone, Gaza Mutkarsh, and I welcome you all to this session on data preparation for BI and analytics. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding data denormalization, and then we'll be looking at data denormalization examples in SQL. So guys, till the previous session we have discussed about the star schema and its implementation and its sample problem statement, let's say explanation with examples. So let's proceed to MySQL workbench. So guys, over here, let's understand the concept of denormalization, right? So denormalization is a process of combining data from multiple related tables into a single table to improve the read performance and simplify the data access. So I'll repeat, over here in the denormalization process, we are combining data from multiple related tables, right? Of course, the tables have to be related, otherwise it will be it would simply be the union of the data. So first of all, the primary requirement is to have multiple related tables in the first place that we can combine. All right, so they can be from the same data sources, they can be from multiple data sources, and we have to combine them into a single table to improve the read performance and simplify the data access. All right, and this is just the opposite process of what we refer to as normalization. So what is the purpose of normalization? Normalization reduces the data redundancy and ensures higher integrity. All right, so normalization is all about getting rid of data redundancy, so we don't have duplicates. A single cell cannot contain multiple values, so we have multiple normal forms, right? So this is where we perform the data normalization. So normalization tends to reduce the data redundancy and it ensures data integrity, while on the other hand, data denormalization prioritizes the speed and the simplicity. All right, over here we are prioritizing the speed and the simplicity, especially useful in reporting and modeling. So let's understand the differences between the normalized data and the denormalized data. So when we talk about the normalized data, so normalized data is optimized for storage and updates, whereas when we have the denormalized data, so it is optimized for read performance. So when we talk about the normalized data, it requires joins to fetch data, and denormalized data does not require much joins. All right, so fewer joins would be needed, or let's say minimal joins would be needed because the data is denormalized. So complex queries means on the normalized data we can run complex queries in the BI tools. So for when it comes to denormalized data, we use simpler visualization queries. All right, so these are the fundamental differences between let's say when in which scenarios we can go for the normalized data, where we can have the normalized data version, and where can we have the denormalized data. So improve the read performance, we need to have the denormalized data in the first place. So having understood the concept of let's say denormalization, let's look at the couple of techniques. So denormalization essentially requires joins and flattens. So we have to apply multiple joins and then we have to flatten the data. So let's say we can store pre-computed aggregates including. So we can have aggregates such as sum, minimum, maximum, count, and even average. So we can have a table where all the pre-computed aggregates are already stored. Then we can even store redundant data, right? So this is just the opposite of normalization, because in denormalization is all about reducing data redundancy, ensuring data integrity, and in denormalization we are, let's say, uh, calling in the redundant data, right, in the first place. So that is how, let's say, the denormalization, these are the different denormalization techniques that we can essentially utilize in SQL. So next, if we were to proceed with an example, so this is an example, right? This is what we'll be implementing. So as far as this example is concerned, let's understand the table structure. So when we talk about the normalized data, normalized design, so we have the sales table over here. In the sales table, I'm passing the sale ID, then I'm having the customer ID, then I'm having the product ID, then I'm passing the date, the quantity, and the amount, right? So over here, I'm having the sales table where I'm passing the sale ID, then I'm passing the customer ID, then I'll be passing the product ID. These are the columns that I'll be creating. Then there will be date, which would essentially be the order date. Then there would be quantity and the amount. Next, we can have the customers table where I'll be passing the customer ID, then there would be customer name and the city. Next, there would be a products table where I'd be having the product ID, the product name, and the associated category as well. So these are the records. So these are the tables that we'll be having in the first place. Now, if we were to proceed with the denormalized design, so over here, what all things we'll be having over here, let's say, we'll have to flatten this data, right? We'll have to combine these three tables into a single table called the denormalized table. So over here, I want to have the flat sales, right? Sales flat. where I'll be flattening these three tables into a single denormalized format of the table. So this table would contain the sale ID, then it would contain the customer name, sale ID, customer name, customer city, product name, category, date, quantity, and the amount. The essential features from all the three tables have been added over here. Let's see what all things we have added. We have the sale ID, then we have the customer name. All right, then we have the customer city. So customer city is present over here. Then we have the product name. So this name is over here. Then we have the product category. So from the product table, we are including the name and the category. From the customers table, we are including the customer name and city. And then from the, let's say, sale table, I've included date, quantity, and amount along with the sale ID. So we have excluded the customer ID, product ID from the sales table, customer ID from the customers table, and the product ID from the products table. This would be the schema design for all these four tables. Three would be normalized, one would be denormalized. So let's proceed towards its implementation. So the first table that we are building is the customers table with these three columns. So the customers table would contain essentially these three columns, and the columns are customer ID, name, and city. So how do we design this table? So over here I'm designing it like this: create table customers, then customer ID is supposed to be the integer primary key. Primary key ensures that no two customers would have same customer ID and it would be not null. The name column in the customers table would be of the varchar. I'm setting this to varchar, and the city would again be varchar 30, right? So this is what I've set as the customers table to. Next, let's say I'm inserting the data into the customers. So what all values am I inserting? I'm inserting the first ID is Raj Sharma and the city would be Delhi. The second column for the second customer, I'm setting this to Neha Singh. The city would be Mumbai. And for the third, Amit Patel, the city is Ahmedabad, right? So we have to ensure that name cannot exceed 50 characters and city column cannot exceed 30 characters. These are the two things that we need to ensure. So I'll show you the data I've already inserted. So I can write it like this: select star from customers. So this is the detail, right? So we have customer ID, name, and the city. Then we have the products table. So product table would contain three columns, essentially the product ID, then the name, and the category to which the product belongs, right? So let's go about creating this table. So over here I'm writing create table products. Then I need to set the product ID as the primary key, ensuring that each product has a unique ID and there cannot be any null values. So which is essentially meant to identify the product. Then this is the name of the product. Again, the name of the product cannot exceed 50 characters, and the category to which the product belongs. So product category should not exceed 30 characters at max. So once I let's say run this command, so the table would be created, but I have already executed it, so table is created, right? Then I'm inserting the data into the product table. I'm inserting the data into the product table, and what all values do I have? Over here I'm having the ID 101. The ID is 101, and let's say over here I'm having the laptop, right? So the first product that we have over here is laptop, and then over here I have the electronics. Electronics is the category to which it belongs. Then for ID2 it is chair, and then the category is furniture. And for the ID3, ID 103, the product is smartphone, and the category over here is electronics, right? So these are the details that I'm inserting into the product table. So once the product table is completed, I can display the data. Over here I can write select star from products. All right, and once I execute this, this is what I'm getting. Over here I'm having the product ID, then the product name, and then the category, right? So these are the three let's say columns that we have in the product table. So we have three records. The next table that I need to create is a sales table. So sales table would be considerably let's say table with large number of columns. So we have to pass the sale ID, then I have to pass the customer ID, then I have to pass the product ID. All right, then I have to pass the date, quantity, and the amount. I'll be passing date, and then I need to pass the quantity, and then I need to pass the amount. All right, so guys, just have a look over here in the sales table. I'm having the sale ID, then we do have the customer ID, so referring to the customer who made an order with this sale ID. Then the product ID, so when the customer is making an order, right, or placing an order, so there has to be some product or service associated. So each product and service would have an associated product ID or the service ID. So this is the corresponding product ID. Then we have the date. What was the order date? Then we have the quantity, the quantity into which this product has been ordered, and then the total amount, right? So these are the details that we have for the sales table. So over here I'm creating this table. So over here I'm creating the table create table sales, and then let's say these are the columns that I'm passing. So over here I'm passing the sale ID. Sale ID happens to be integer, and this is primary key. Then the next table that we have over here is the customer ID. The customer ID is again integer. Then the product ID, I'm setting this to integer as well. Then we have the date table, date column, which is the data type is date. Then the quantity, I've set this to integer, and the total amount would be decimal 10 comma 2. Means after dot it can take two digits, and the total would be 10 digits in total. But over here, because the customer ID and the product ID we don't have in the sales tables to begin with, so over here we need to map it with the associated primary key from the other table. So I need to set the customer ID as foreign key, which is what I'm setting over here. Foreign key bracket customer ID, and this should refer to the table. This should refer to the table customers. It would refer to the customers table, and the column would be the customer ID, right? It would refer to customers table customer ID. So references customers table customer ID. Then we have the foreign key, and in the foreign key over here, the second foreign key would be the product ID. So this is the column which is referring to some other table primary key. All right. So foreign key product ID, and it refers to the products table. And in the products table, again, we do have the product ID. So this is how the customer name and product ID have been integrated into the sales table, right? So once I've created this table, let me insert the values. So this is where I'm inserting the values, right? So this is the sale ID one. Then we do have the customer ID one. Then the product ID is 101. The order date is 2025-601. The date is let's say the quantity is 2, and the amount that I'm passing is 1,50,000. Then for the sale ID 2, the customer ID 2, and the product ID being 103, the order date is 2025-601, and the quantity is 1, the total amount being 40,000. Then for sale ID 3, customer ID 3, product ID 102, the order date is 2025-602, the quantity ordered is 4, and the amount is 20,000, right? So this is the details inserted. So I can write select star from sales. So as we can see, the data has been inserted. So this is the table structure. So let me combine all the three table structures over here, and then we'll move to the let's say the denormalized table. So in the sales table, this is the table schema, right? This is the table schema for the sales table. And how many records do we have? We have 3 records. In the sales table, we have 3 records. This is the first table. Then next we have the products table. In the products table, what do we have? In the products table, the columns are these are the columns, and we have 3 records. These are the column in the products table, and we have 3 records in total. All right, and next we have so this is the sales table, this is the product table, then we do have the customers table, right? So over here I'm writing select okay, this should end with semicolon. Then we have the customers table. So this is the customers table, and in the customers table again we have how many records? In the customers table again we have 3 records, right? So customers has 3 record, and what is the schema for the customers table? So the schema over here is customer ID, name, and city. So this would better help us understand the table structure when we'll be solving the questions. So we have the sales table, the products, and the customers. These are the 3 tables that we have, and we have seen the table structure, right? So 3 records each, 1, 2, and 3. And yes, this is what we started with: sales, customers, and product. So now we can move to, let's say, the denormalized table. So I'll be calling the denormalized table as the sales flat, because I'm flattening the 3 tables into the sales flat table. So over here it's highly conceptual, so let's understand this. So what all columns do we need for the sales flat? For the sales flat we need the columns. Let's call this the sales flat. All right, and sales flat would contain the sale ID, then it would contain the customer name. All right, so over here I'm having the sale ID, then I do have the customer name. then I need to pass the customer city, then I need to pass the product name, then I need to pass the category, right? So we have sale ID, then I am passing the customer name, then I'm passing the customer city, then I'm passing the product name, and then I'm passing the category, right? So these are the details. These are the columns that we have. So these are the columns that we wish to incorporate, right? So first of all, we'll be creating the table, then we need to insert the values. So we won't be manually inserting the values, rather we'll be inserting the values from the pre-existing tables that we have. All right, we'll be using the pre-existing tables that we have. That is how we'll be inserting the data into this table. So let's understand this. So how am I creating the sales table? What is the syntax? So over here I'm using create table sales flat, and then in the sales flat table, the first column would be sale ID. This happens to be integer, and I'm setting this to primary key, ensuring that each and every order ID or the sale ID has to be unique. It cannot contain any null values, which would uniquely be identifying each and every sale or the order placed. Then I'm passing the customer name. It happens to be varchar 50, means no customer. I can set the customer name to have more characters than 50. Then I'm passing the customer city, and I'm ensuring that customer city cannot exceed 30 characters. Next, I'm passing the product name. Over here I'm ensuring that the product name cannot exceed 50 characters. So I'm setting the varchar as 50. Next, over here I'm passing the category, and I'm ensuring by writing varchar 30 that the category of the product ordered should not exceed 30 characters. Next, I'm passing the date. So date is nothing but the order date, and I'm setting it to date data type. In the quantity, I'm setting this to integer, and the amount would be decimal 10, 2, means total 10 digits, and after decimal 2 digits. So let's create this table. So once I execute this table is already created. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 fields. So I'm having 8 fields in this sales flat table. Now comes the most interesting and the important part, that is to populate the data in the denormalized table. So over here I need to populate the data into the denormalized tables. So how do I go about populating the data into the denormalized table? So this would require inserting data into sales flat from the other tables. So what are the other tables that we have? We do have the customers table, we do have the products table, and we do have the sales table, right? So these are the three tables that I'll be using to insert the data into the sales flat table. So how do we insert data from one table to another table? This is a kind of query that we'll be discussing for the first time as far as this module is concerned. So over here, just observe how are we inserting the values. So this is denormalized insert using the joins. Denormalized insertion. Okay, I should rather write insertion into the denormalized table. Insertion into the denormalized table using the concept of joins. So because we do have these three tables, right, and the three tables that we are discussing is nothing but sales, product, and the customers. So based on these three tables, we'll be populating the sales flat table. So this is what we have to begin with. Now we have to go through the tables structure, and then maybe we can proceed. So let's have a look at the table structure that we have, or the table schema. Yes, so we have sales, product, and the customers. So we need these columns, right? So insert into sales flat. I need to insert the data into the sales flat table, and the sales flat table contain these columns. So these are the columns that we have in sales flat, right? So the sales flat table contains these columns. Now I need to insert the data into this table. Let's see how. Over here I'm writing insert into sales flat, then I'm passing select, then s dot sale id, then I'm passing c dot name as customer name, c dot city as customer city. So this is the table structure that I need to populate. Alright, so see, where am I fetching sale id from? S dot sale id. So s would refer to the sales table over here, right? Because this is where we have the sale id. So s over here is referring to the sales table. Then I'm passing c dot name as the customer name. So c dot name, so c would be the alias name for the customers table where I'm having the customer name. Next, I'm passing the customer city. So again, c dot city. So c dot name and c dot city are fetched from the customers table where I've used c as the alias name. Then I'm writing p dot name as the product name. So where am I fetching this p from? So p dot name would be the products table, right? P is referring to the product table. Next, I'm passing p dot category. So again, the category column is present in the product table. So I'm referring to the products table with the alias name P. Then I'm passing s dot date. So where is s dot date present? S dot date is present in the sales table. So I'm calling, see, s dot sale ID. I've used the sale ID. So s indicating the alias name for the sales table. Likewise, s dot date indicates that the alias name for the sales table that I've used is s, and this is where I'm fetching the date column from. So after the let's say for sales flat, we need sales ID, customer name, customer city, product name, category. So besides this, I need the date, quantity, and the total amount, right? So date, quantity, and total amount, again I need to fetch it from the sales table. So after category, we have to pass date, quantity and amount as well. So after category, date, quantity, and amount are also present, right? So let's see how do we insert them. So for date, quantity, and amount, date I have to fetch from s dot date because date is present over here. So again, s dot date, s indicating the alias name for the sales table. So this is where I've passed s dot date. Then quantity is also present in the same table. So this is s dot quantity, and even the total amount is present in the same table. So s dot total amount, s indicating the sales table, right? So this is the quantity. So this is the data that we have, and this is how I've inserted all the columns. So S indicates alias name for sales table, C indicates the alias name for the customer table, P indicates the alias name for the product table, right? And now over here, I need to address the tables. I need to address the alias names along with the corresponding join that I need to apply. So over here, I'm passing, these are the S, C, and P. So from the sales table S, sales has been aliased as S, and then I'm joining it with the customers table C. C is the alias name for the customers table. What is the joining condition? The joining condition that we have over here is S dot customer ID. The customer ID column from the sales table should match with the customer ID column from the uh, customer table, right? This has to match. Then over here, I'm passing, next I'm joining it on the products table P. So on, what is the joining condition? S dot product ID should match with P dot product ID. So over here, I need to ensure that the S dot product ID should match with the P dot product ID, right? So these two should match. So once if I execute this, so see in the insert query, this is for the first time that we are using the select query. So even this way, data can be inserted into the table. So now if I run this select star from the flat sales, so this should end up displaying the data. Now we have not populated the data from the scratch. We have not manually entered the data. Rather, we have populated the data from the pre-existing tables that we had, or the normalized tables that we started with, right? Essentially, the sales table, the customers table, and the product table. So over here, I can see the sale ID, the customer name, the customer city, the product name, the product category, the order date, the quantity, and the total amount. So next, maybe we can solve a couple of questions based on this denormalized table. So maybe I can find the total sales by category. So I can simply say select category by sum of amount as total sales from sales flat group by category. So this is category wise total sales. Next, if I want to see what is sales by city, so over here I'm using select customer city comma sum amount as the city sales from sales flat group by customer city. Alright, so this is customer city wise total sales. So maybe I can combine the two. So maybe I want to know the category and city wise total sales. Maybe I need to know top two products. So top two products by quantity sold, right? So over here I'm writing product name by sum of quantity as the total quantity from the sales flat group by product name, and then over here order by total quantity in the descending order and limit 2 because I need only top two. So the top two products, product wise quantity is chair has been ordered 2 times, chair has been ordered 4 times, and the laptop has been ordered 2 times. So this is how it can be implemented. Maybe I need to know the total sales per day. So over here I can write date wise sum of amount as daily sales from sales flat, and then over here I can mention group by date. So next, maybe if I wish to know, so what is the data? Now I want to know, let's say uh, city and product wise total amount. All right, I want to know, okay, category and because we have less records, so let's do one thing. Let's find the category wise total amount, right? Or category wise, I think we have already computed the total amount. So this is already done. Okay, no issues. So let's try to compute category wise, category and product wise total amount. So besides category, I want to know the category and product wise total amount. All right, so this is category I've already added. Then the product is product name. Let's check the tables structure. So we do have the product name, right? Category and product wise total amount. So this is category and this is product name by sum of amount as total sales and group by category, and then over here I can mention the product name as well. So if I run this, so this is category and product wise total sales. For electronics category, for the product laptop, the total sales is 1,50,000. For the electronics category, for the product smartphone, the total sales is 40,000. For the furniture category with the product name is chair, the total sales is 20,000. So guys, now we have understood and let's say implemented the concept of denormalization, and we have implemented the corresponding queries in SQL. So that brings us to the end of this session. Let's switch to the PPT. So guys, in this session, we have understood the concept of denormalization and the corresponding associated concepts. How to proceed, how to take denormalized, normalized data and then proceed with its denormalization. And we have implemented the corresponding SQL queries to achieve the denormalized or the flattened format of the normalized tables that we started with. So guys, in the next session, we'll be moving on to, let's say, flattening the hierarchies, queries related to flattening hierarchies in SQL and in Power Query in Excel as well. Thank you.